Good morning, everyone. My name is Omid Afnan. I'm a program management lead with a big data platform team at Microsoft. I've been working on big data platforms for the last 7 or 8 years. My main focus has been, in the past, was a platform called Cosmos, which some of you might have heard about. It's our internal big data platform, which I'll talk about as we go, just as an example. More recently, I'm responsible for especially developer experiences around our Azure Data Lake, HD Insight, and Azure Stream Analytics services. So today's session, the objective is to try and help people understand a little bit about the changes in traditional data landscape that is going on, and at least how we see it, and from our customer conversations, what we've heard back, what kind of challenges people see, what kind of opportunities are out there. And then really try and give you an idea of how Microsoft and Azure try to make that easy. A lot of the focus on my discussion will be about how we make big data easy, partly because we feel that big data traditionally has been very challenging, very difficult. And it has been kind of a rocket science kind of thing and a very enthusiast space in the past, but now it's becoming democratized, it's becoming widespread. Many organizations, many individuals are using it. So we think that ease of use is key, it's critical for further adoption and for you to be able to unlock what's going on with big data. We also really do focus on making the power of big data available, and not just to make you easy to get started or make it easy to get started, but also to be very powerful tools and capabilities down the road. But I'm going to talk a little bit more about the sort of getting started and the fundamental architectures that big data is driving right now. Just to help me understand who's in the room, just a quick show of hands. How many people are already working with some kind of big data stack? Maybe it's Hadoop, maybe it's Spark, maybe it's Azure Data Lake, something at AWS. Okay. And how many people here would consider yourself developers? You're doing some programming and coding, and you can put your hand up for more than one. How many people are data scientists or would consider yourself in data science? How many people are more like business decision makers, management, et cetera? Okay, great. So we have a good mix of different kinds of people in the room. So yesterday and today, there have been other sessions focusing a little bit more on in depth on USQL, which is a language that I'll talk about as well. There's been sessions about Spark. There's been sessions about some Hadoop technologies. So in this session, I will try and talk a little bit on purpose, a little bit more about the architectural view and sort of how these things go together. I'm going to talk about Azure Data Lake services in particular, what the services are. But because other sessions cover some of the technology details, I will give you some demos hopefully, but we're going to talk a bit more at the architectural level. So traditional data warehouse, this is a Gartner quote saying that it's coming, we're at a tipping point. There's something happening in our data space which is moving us beyond or is expanding the edges of what our idea of a traditional data warehouse might look like. This is a very simplified diagram on the right for the purpose of this discussion, that our traditional data warehouse has a bunch of well-known data sources. There's probably a very extensive and hard to maintain, possibly ETL cycle or ETL pipeline that has to happen on top of those sources, which results in our data warehouse, in our highly curated, highly modeled data warehouse, which finally then probably feeds a BI and analytics data system or analytics environment. So this is hopefully something, or probably something that each one of your organizations, each one of your teams is very familiar with, and you probably have been working with this or around this for a long time. And what's happening is that big data, we feel, and so is Gartner is agreeing as well, is driving some transformative changes, which I'll talk about in a moment. But as far as definition goes for big data, you probably will have heard about the 3 V's, so that you can have high volume, high velocity, and high variety. And something we often tell customers, or we hear from customers as well, to have big data doesn't mean you have to have all 3 of those at the same time. Often you start with one of those angles, that you have a high volume and you're not sure how the best to deal with that. Or the velocity of the data coming through in something like a fraud detection scenario. Might be the volume is not very high, or the individual units of data, even the sum of the data is not high, but the velocity that's coming in at is a challenge. And of course, variety, the kinds of data that we're talking about now with social media, with video, with all kinds of binary formats, IoT devices, that any one of those, for example, use case around video processing, which was mentioned, I think, by Joseph in the keynote, for example, that by itself can put you in a big data scenario. So the point is how to take all of that and drive some kind of enhanced insight, better decision making, and possibly some automation. So transformative changes, we probably think about in at least these three axes. What is the characteristics of the data that's changing or increasing? What is the cost question here, or like how is the cost base changing in data? And what cultural changes are either driving this or more likely being driven by the coming of big data? So the characteristics, I think, very simply put here, is that we used to think about data, and we still do, as highly relational, kind of the rectangular data that was referred to in a couple of the talks yesterday and today, and with highly modeled schemas. And big data is driving this multi-schema, variable schema, changeable schema kind of environment where the data has a lot of different styles and types, and they're not constant. You might say, well, today I figured out the schema of the JSON that I'm using, I understand it very well. Or the device data I'm getting from my connected car, I have a format. You well know that tomorrow and then the next generation, the next version of that vehicle, probably some engineer twiddled something and your data format's no longer the same. So this kind of environment, this kind of schema agility is really a part of this transformative change. Something I want to enforce here is that certainly in the big data team, we don't have the idea that the things on the left are necessarily being replaced by the things on the right. So I'm not here to tell you, well, relational data is gone or not important anymore. Obviously, that's not true. It's kind of here to stay. And not just relational data, but data that's stored in a data warehouse, in a data mart, and in those ETL pipelines. Those are more than likely going to stay and continue to grow. So this big data piece is really additive in a lot of ways. And that's part of what the architectural talk today is going to be about as well, that how do we manage adding big data, and how can we leverage some of the things we already know to make that easier. The cost part is interesting because in the past, and even today, there's a lot of commodity hardware, a lot of custom hardware, a lot of expensive hardware that's built around storage networks and around specialized processing hardware. The move in big data is completely towards commodity systems. So whether it's for the Bing platform, which is the genesis of a lot of big data at Microsoft, big data technology at Microsoft, or it's the Google technologies, they were all really based on taking commodity hardware, very common, sort of almost like your desktop machines, and using thousands, hundreds of thousands, almost millions of those machines to get a task done. And what that drives, aside from cost point changing, is that any big data system that uses that kind of stuff has to deal with failures. Now, when we're talking about having 100,000 machines to do something, and they're commodity machines, you're going to have constant failures. You're going to have machines failing. You're going to have to, they can be soft failures that you can recover from. They can be hard failures. But a big data system or a distributed platform like the one we have has to be able to deal with that. So some of what you'll see in our demos later, you'll see us, how does the system deal with that? What do we do around that? And of course, culture-wise, a lot of what's happening is that, again, Joseph referred to this in his keynote, we've been in a place where a lot of BI has been kind of this rear view reporting, looking back at what happened, trying to understand what happened in the past. And big data is helping us make a shift towards some of the forecasting, some of the prediction, some of the sort of forward-looking intelligence that we would like to get. And of course, that brings in a lot of stuff that, again, has been touched on in a few of the talks about machine learning, especially streaming data, things like that. So one example here, or one kind of customer case I wanted to mention, a company called Tangerine. They used to be called ING Direct. It's a bank. They have been recasting themselves, reinventing themselves as a sort of agile, modern bank. They had always been kind of a newcomer bank in their market, but they've tried to shift and become really very customer focused and say, we're going to be providing a lot of online services. They're going to be on desktops and mobile phones and all kinds of devices. We want to change the experience automatically as people use these things. And we want to be sort of like really next generation, young millennials want to use us, all of that. But we want to not build a fancy platform and hope for the best. We want to be an experimentation culture. We want to try things out, like say, hey, we think our users want this. We want to push it out and pull it back if we get immediate response that people are not liking this. Or if they like it, we want to accelerate the rollout. And they wanted to pull together the call center interactions they have, the online interactions they have, and make that all into kind of a product feedback channel to say both the technology and the banking products themselves, are these meeting the needs of customers, and can we be agile? So I've taken this strategy and used Azure HD Insight, which we'll talk about, the Hadoop service we have, as well as something called APS, which is an on-premise solution. So we put some on-premise and cloud together and are currently running this environment. So you can see the quote there that talking about creating predictive, context-aware financial services. That's their goal. And this is a real use case. These guys are running on Azure today. So let's take a look for a moment at why data lakes or why a data lake pattern. What does that mean? So as I mentioned, for the traditional process for business analytics, it looks something like this, the circle on the right. We start out with some new requirements, identify the data schema, the queries that we want to run, the sources of data have to be figured out. Based on that, we create an ETL pipeline. We have usually a complex process of modeling and cleansing and so on. And based on that, you can finally create the reports and analytics. And of course, this is an endless loop, right? We keep finding new requirements, we keep finding new things we want to do. And often this loop is time consuming, of course, and usually takes a bunch of experts and maybe an IT department or specialized groups to help you get this done. Again, nothing wrong with that. The message here is not that this is the past and therefore it's somehow either low tech or undesirable. This idea of taking data that is inherently relational or things that come from line of business applications, feeding them through a pipeline and getting a defined schema, that's a highly useful thing that we continue to do. But some key things here, one is the fact that whatever data we don't use now, so in that requirement cycle, in that report generation cycle, there's some data we don't need or we don't use. We say, well, throw that out or don't keep it. So it's either archived in the best case or maybe discarded outright. And as I mentioned, this circular process usually has a long latency for something to get through it. So the big data thinking is there's a fundamental difference in that it says, well, all data has value. That value may be today, it may be tomorrow, it might be a year from now. But if we have the data, we should keep it. It has potential value. And we want to actually be data hoarders. Now, why is that possible? Well, as I mentioned, the price points changing, the commodity hardware, the large-scale storage that we enable through big data. This all makes this now possible. You could always have done this. Of course, it would have cost you a lot of money. And it would have had a lot of implications probably for the equipment you have to procure and all kinds of stuff. So in big data, we're saying step number one, get the data. Don't worry about the schema. Take the native format. That's kind of the maximum fidelity of data you have. Put that in the system. And later, we can do this iterative thing where we say, well, I have a question now I want to answer. There was a very interesting talk yesterday about sort of big data for everyone. And the presenter was talking about sort of asking the kinds of questions you can ask, whether they're ambiguous questions or sharp questions. So at first you might have very ambiguous questions. You say, I want to understand the usage of my web service. So you start collecting all the data. As you come up with those sharp questions, you say, well, I want to know the number of users who came to my service yesterday and the number that failed out. Then you can say, well, all the data is here. I write my query. I impose a schema. I make a query. I read some data. I create a report. And then tomorrow when I say, well, I want to learn something more, I want to now find out about a specific kind of error that happened for my users. Then you can say, well, now I've got a new query I have to do, but the data is all still there. And I can go back and mine a new part of it. Not only that, but 6 months from now, a year from now, if you say, oh, I have a new definition on churn. I want to see what my churn rate looks like on my service. You don't have to say, well, from this day forward, I have this new churn. I can say, well, from the beginning of my time, from 6 months ago, I can reapply this churn calculation. So it's a very different kind of environment. We're used to data, sort of only having data we need, and when we have new requirements, they're kind of from that day forward. In the big data world, in the big data thinking, these are no longer true. And that's part of the empowerment of the big data concept here. So the data lake and the data warehouse, so these are not, again, separate things, or they're not contradictory things. On the top part, what I'm showing is the data lake suggests exactly what we had in the last slide. You're going to have all these things like device information, telemetry, social feeds, which are highly unstructured, semi-structured, Twitter feeds and Facebook posts. We have things from the web logs. We have video files. All of these, the goal for the top part of the picture is grab them, dump them into this lake. So a lake, all rivers or all streams in an area flow down into a lake and the water collects there. So same thing we want to do with our data. So those purple boxes are kind of the things that are natively being captured and put in the lake. And those gray boxes, the batch queries, interactive, real-time machine learning, these are different ways that we can interact with that data. Batch queries being the basic, usually starting point for most organizations, because it's that saying, okay, let me think about, I got a bunch of data here, let me go read that data, think about a question I want to answer, try and fiddle around queries until I get the answer, and if I get it right, let me run that every day or every week or on demand. But very quickly, organizations move from that to saying, that's great, that helped me start my big data journey. It helped me to get my big data, understand something about my big data. Now I want increasingly to let users just get interactive data. I want to be able to say what happened in the last few minutes. I want to say, have a ad hoc query for my users directly. And in parallel with that, there's a real demand for real-time analytics. More and more, it used to be people start with batch, and eventually they get to the point where they want to do near real-time processing of something. Today, we see people coming up and saying from the beginning, I want to start with near real-time. I need to capture streams of data from my IoT. I need to look at financial transactions and trigger alerts or detect fraud. So the top part, those gray boxes will create either, let's call it cooked data or aggregated data, which can go back into the data lake. Often that's the case. You just keep building more highly aggregated data sets in your data lake because that's a great place to keep them. But another thing that happens often is that data goes down into our more traditional data warehouse. It goes into some RDBMS. Why does it do that? There could be a couple of reasons. One, because you want to use some existing tools, some existing reports, some existing BI with other relational data you have, and you want to join these things, and it makes sense to put it close to where that relational data lives and use your existing architecture for that. Could also be that, I mentioned that batch to interactive piece. So one easy way to take the big data processing you have and enable a kind of low latency or interactive scheme is to put some of that cooked data into a database and then use like BI tools or use Tableau or use whatever you want to kind of have interactivity at that level. And I also show here that often from that traditional relational data you have, there's a path up into the big data processing, because there will be that, where I say metadata and joins, there will be reference data that often lives in the relational warehouse, which you want to pull out and merge with your big data work to get your complete reports. So the point being that not only can these two things coexist or need to coexist, there will be interaction between these two sets of data or these two kinds of data that you have. And of course, as was mentioned in several presentations, the bottom part, the relational data system, can also be cloud-based. The top part is, in the Microsoft world, is always cloud-based or primarily cloud-based. The bottom part is also enabled through Azure SQL DB and Azure SQL Data Warehouse. So this whole solution could be cloud-based. So as I mentioned, big data is not easy. There's a few key reasons it's not. One is skills and capabilities. So those of you who have been working on Hadoop or Spark, for example, depending on how long you've been doing that, either you're one of the few who has that skill, or you've tried to hire people in your organization, and you know how hard it is to get some of that. So there's some skill gaps. In data science, of course, it's a rapidly expanding field, but there's still a critical shortage of finding good data scientists. That's one thing. The middle part is understanding how to extract value from this data. We're saying there's a lot of value there, but it's not trivial. It's that cultural shift that needs to take place to understand what we can do with the data and what to look for is key. And of course, this integration with existing IT investments, that sort of previous diagram saying, how do we connect, where do we connect? This is a key question. At Microsoft, as I mentioned, I just want to give you as a quick credential check, if you like, for Microsoft, is that in the last 10 years, we started at a point where Bing as a search engine was a very low percentage of the market. We had goals to say we want Bing to become a huge player in the search market. And we went something from low single digit market penetration to around 20% market. And how do we do that? One of the key things was to try and shift our culture to say we need to collect a lot of data about how people use search engines and use that customer behavior to drive features and also to understand failures and customer satisfaction. And we need to do all of this in an experimentation culture. So we built this thing called Cosmos, which I mentioned earlier. Today, there is something around 15,000 Microsoft developers who use that on a monthly basis. And we're at the exabyte level of data storage. Data under management is in the exabyte scale now. And it's not 1 exabyte, it's not like 1.1, it's more than that, several exabytes of data. And it's become, all of the teams at Microsoft, essentially, you'll see some of the names there, it was driven by Bing, it was driven by Office 365, these online platforms, but now almost every product group at Microsoft uses Cosmos for its storage. So we've taken that technology and that experience, and this is what we're baking into our Azure Data Lake offering, which I'll talk about. And we're hoping that this will really give all of you a head start or a boost in terms of being able to approach big data. So patterns for big data, let me just build this out. So I think a key starting point for big data analytics is data flow. This diagram is based a little bit on a diagram we've all seen in other places. where we kind of start on the left with our sources, so business apps, custom apps, sensors, all of those. And we go through a few layers of Microsoft technologies, or anybody's technologies really, to get on the right towards actual insights or action. So, sorry, went too far. So the main point here is that there's kind of, you can think about a data flow, and then you can think about a logic flow. So from a data flow perspective, there's two major categories. There's the bulk ingestion of data, and then there's the event streams. And bulk ingestion, there's a number of tools that Microsoft offers, but in general, this is where most people start. You have JSON files created somewhere. You have server logs being generated. You have image files, and you need to copy these into your data lake. And this is usually achieved through some kind of client-to-cloud copy service. We have several of them available in Azure, but you can also write your own. Whereas the event ingestion side is where things like Azure Stream Analytics, event hubs, things like that come in. Because here now we're talking about some flow that has to happen in near real time. But regardless, all of these types of ingestion can and should go into this service called Azure Data Lake Store. You can also use Azure Blob Store, so that has been around for a long time. In a moment, I'll talk about what's the difference between those. But Azure Data Lake Store has the sort of the automatic scalability and schema flexibility and everything else that we've been talking about so far. Then the preparation, the analytics, machine learning, all that's going to run on top of the data lake store and feed into your discovery and visualization. So this view is especially simple in the case of bulk ingestion. You take a bunch of files, you drop them into the data lake store, you run this analytics on the gray box, you can go to your discovery visualization phase. We'll come back to a bit more detail in a moment. The event ingestion pattern, as I mentioned a moment ago, is a little bit more work, or a little bit more complicated, let's say. Again, starting from the left side, same kind of framework here. Events are going to go through Azure Event Hubs. If you're starting from scratch and you don't have any investment in any other technology, Azure Event Hubs is a great hosted service for helping you manage streaming events. A lot of people are using Kafka if they're coming from the open source space, from the Hadoop space. Equally possible to do that in Azure, or to do it on premises and connected to Event Hub. These events will flow through, and the processing part for event ingestion is going to be around one of these things here: Azure Stream Analytics, Storm, which is a Hadoop community project, or it's going to be Spark Streaming. And this transformed data is going to, again, you'll probably end up putting both the raw events into the data lake store if you want to have some the ability we talked about before of long-term reuse of that data. But certainly the transformed data, the cooked data, the processed data would end up in Azure Data Lake Store, as well as many cases directly feeding into a dashboard, into a Power BI type of environment. So the key thing that we see, and you'll see in the literature as well, is this kind of Lambda architecture, saying most organizations, whether it's day 1 or day 100 or day 1000, are going to end up in this kind of mode where there's the two things we just talked about, the bulk ingestion and the streaming, will come together. So there's basically a hot path and a cold path is another way of thinking about this. The top part is the hot path. It's the streaming part of this. And this diagram with the names changed to protect the innocent is actually from a customer of ours. I've changed it a little bit to make it slightly more generic and generalized, but this is actually that we have customers in service who are using this. So on the left, things start out, of course, on-premise. On-premise may mean not just your data center, but of course it could be many locations. In the case of IoT, it could be distributed locations around the world. But things start from outside the cloud, outside the Azure environment, and they're going to get loaded. The hot path will get that kind of event hub kind of model I mentioned. The hot path, the streaming path, almost always will have to pull in some reference data. So there's a question of preparing and loading some reference data, which could live just in the big data environment. Often it comes from that relational data store that we've all know and love in our IT environments. But these will get sort of flattened and joined in this case, I'm using Azure Stream Analytics. That's that kind of wavy gear symbol there. And again, Event Hub at each stage becomes kind of like a buffer, kind of a way of handling these messages around. So in the ingestion phase, it's just a flatten and join with metadata. Then it gets into a prepare phase where, again, these customers will run different set of ASA rules because now this is they're actually saying, for example, we want to group certain kinds of data together, or we want to channel streaming data that has to do with maintenance events separately from one that has to do with installation events or something like that. And then in the analyze phase, again, so you'll see this pattern of event hub, like a event queue, a processing rule to another event queue. And there could be multiple event queues that it goes out to. But in the analyze phase, this is really where you might be calling out to Azure Machine Learning. So you have a prepared, this is not the training phase. You've trained the model, you have a scoring function. Azure Machine Learning lets you publish that as an API call. So now your ASA job can, or whatever processing you're using there, can call out to machine learning scoring functions on the fly and take some action. So then that can be published. The results can be published to a dashboard. They could, of course, go through SDKs and APIs and go through to some other custom code that you've written to take some other action. And then the bottom path is the so-called cold path. This is where we're taking data, often things like massive logs, let's say server logs, or collected image files like the example we had yesterday. And these are being loaded into the data lake store. Data Factory is something that's very useful here. Data Factory is an orchestration and scheduling platform for helping you to take things from step to step. So Data Factory will help can do a sort of drag and drop web-based model for setting up your data ingestion. So in this case, this particular customer is taking a lot of things from their hot path and that are going to Data Lake Store. But in the cold path, they're doing a batch scoring job. So they're taking many, many events and doing scoring sort of an overnight on those things to learn other things. So the real-time scoring might be you can imagine this could be for fault detection or fraud situation, whereas the bottom part is more for trends and for forecasting. So the bottom part, you have some offline training happening in the prepare column there. You have data lake analytics jobs running in the analysis phase. That's the batch mode work that can be done. And again, we're going step through step to put things in the data lake store is always the backing store for all of this. But we can also publish, and this customer does, they publish to Azure SQL Data Warehouse at some point because again, they're running some existing line of business applications. There's some existing web apps that you don't want to change. That's fine. You can do it in this model. Let me take another example here, just to keep going on the same architectural vein. This is small. I don't know how well you can see that. Let's see if we can zoom a little bit. So actually, before I zoom, so this is a leading computer manufacturer. If I told you the name, you would know who they are. This is for their retail side of things. So people go on their website, they assemble laptops or desktops or whatever they want to buy. They select configurations, and they go to a checkout experience. So what do they want to do? They want to analyze click streams and provide recommendations. Very common case, of course. So the way they built this, I'll just zoom here a little bit in the hopes that will help. So in the middle, these blue boxes, Omniture, product catalog, visitor information service, these are existing things. These are, again, relational type databases and web systems that they already had. So these are sitting in the middle. Now, they want to do that kind of Lambda architecture we talked about. So the bottom here is kind of that hot path where they're taking events from Omniture. They're taking events from the website as people are going through and doing selections on the shopping cart. And they're feeding it through the NRT system. They're feeding it through a Storm setup to be able to sort of figure out what's going on. And they're calling on Azure ML. The Azure ML here is calling, again, it's the scoring function. It's not the training part of things, saying, here's a bunch of clicks, and if I see this pattern, score for me, what is the likely thing the person is looking for? What is a product recommendation I can do? So the outcome of this is to actually push, you'll see it says in the middle, recommendations, push recommendations to the website. So this hot path is all about, we already know something about customer behavior. We're tracking what's happening right now. We're pushing a recommendation. The top part, if I can come up here a little bit, so the top part is doing something else. It's saying now, targeted emails. We want to do things like, people left their shopping cart without completing a sale. They came and browsed a bunch of stuff, and we want to get back to them. Or they bought stuff, and we want to email them and say, hey, here's a new product you might think about. So this part is, again, feeding off the same middle tier there, the same relational data. This particular instance is interesting because you'll notice that this customer is not using Azure Data Lake Store. They're going off basically the relational data they have plus some blob storage. So I put this in here as kind of a counterpoint that it doesn't have to be Azure Data Lake Store, which is a highly managed service. It can also be Azure Blob Store, and you do more work to move things around. So in here, they're loading things into blob storage from Omniture, from the product catalog, and then they're firing up HD Insight clusters and running Hadoop jobs, running Hive, Pig, to do the processing, and feed data into Azure ML as well, so it can do its training model. So the Azure ML we're doing the training to provide the scoring that I mentioned before, but the HD Insight cluster is also building the information that you would use for doing your targeted emails. So all of this data pumps out they use a VM on IaaS to do some more processing, and finally they can take the templated email, the email templates and the addresses and the data, push it out to their email system, and off they go with targeted emails to users, which can then feed back into more users click on their website. They can measure the efficacy of their campaigns and so on. So this is, again, this is a real implementation. They use Hadoop extensively in this case, a lot of clickstream analysis. So how are we doing on time? Let me continue. So making big data easy. So this is the kind of architecture we're seeing people use. It's the kind of thing we would probably recommend to you if you came and talked to us about, hey, how do I get going? What are some of the things that Microsoft does to make this easier? Sorry, this build is not right. Okay, so apologies. So setting up for big data, so if you're using Hadoop, for example, these are probably or Spark, these are a lot of the steps you have to go through. You have to figure out which open source stack you want and which version of it you want. Are you going to go with Hortonworks or Cloudera, or you just go straight Apache? You're going to have to select a whole bunch of components. Do I want to use Hive or Pig or both? Do I want Tez as an engine? And then you're going to have to go through hardware sizing and requirements and procurement. And once you have all of that stuff, then the fun starts, because you have to set up some kind of installation management service like Ambari. You're going to go through setting up your whole cluster, pushing out the bits, so on, and then finally going to start configuring and tuning. So you can see that it's going to be work. It's going to be a steep learning curve, and there's going to be a bunch of work. And it's going to be slow because you're going to have to procure the hardware and do a bunch of stuff that just naturally takes time. So let's take a quick look in terms of demos. I'm going to switch here. Hopefully we're still good to go here. Okay. Yes. So I think in some of the sessions you've been at, you've probably seen this. This is the Microsoft Azure portal. I'm looking right now at my dashboard, which is a bunch of things I've pinned here in terms of just some general service health indicator on that map there. I've pinned some specific services on this thing. But what I want to show you is, that slide we just talked about in terms of setting up. Let's say you're not even using Azure Data Lake Analytics. You just want to use Hadoop on Azure. What would that take? So go here to everything in the Azure portal starts, if you want to create a service, starts from this plus button to do something, to create a new instance of a service. I go, say I want intelligence and analytics, and I see that I have HD Insight as a choice. So HD Insight is our hosted Hadoop. It's a Hadoop in the cloud offering from Microsoft. It uses standard Hadoop components, fully Apache-based. Hortonworks helps us have the right kind of stack here. Nothing different about it than any other Hadoop environment. But I just want to say, so here, I'm going to set up my Hadoop cluster in about 1 minute. So first thing I have to do is give it a name. So we'll say it's my cluster for this conference. I pick a subscription that I'm going to use for charging and billing of this thing. I'm going to select a cluster type. So here I have a few choices. I can say Hadoop, HBase, Storm, Spark, Kafka Preview. Let's just say standard Hadoop. It gives me a version choice. I can choose Linux or Windows. I can have a choice of versions. And I can say, do I want the standard SKU or the premium? The premium has Microsoft R server in it, which a lot of people are interested in. So I'm just going to pick standard and say select. I'm going to have to create some credentials here. So I say there's an admin, and here's the password. And because it's a Linux one, there's an SSH login possible here. So I'm going to create a password and user for that as well. And I'm going to pick a data source. So here my data sources can be storage accounts could be Blob Store, could be Azure Data Lake Store, could be any of those two kinds of storage. So let me just pick a storage account I already have. It's located in a East US data center. I have lots of choices, but that's the one I'll pick for now. And I'll come down here and say, let me choose pricing and cluster size. So here I say, well, how many nodes do I think I want here? 4, 10, 20, 100. I'll leave it at 4. And I can pick the worker node and head node SKUs. So if I say, well, let me just look worker nodes, I can get a 4-core and 8-core system. I can get more RAM if I think that's what I need. I can choose any one of these and it'll give me the estimated price. So I pick. So right now I'm going to create a 4-node cluster with 1 head node. 2 head nodes. I've picked the D4 SKU for my workers. I'll say select for that, and I'll say select for this. And basically I've done everything I need to do. I can say pin to dashboard when it's done, and I can say create. Oh, sorry, I should have created a resource group. There we go. I can say create. So now this is going to start this creation. It does give me a little note here that could take, says 20 minutes or so. You'll see up at the right here, deployment started. So I can come back and check this later. But that's all it took. I didn't have to think about, what installation service is being used, where to get the bits. I don't have to think about machine procurement. So 20 minutes to get your nodes up and running, I think is probably faster than most of our procurement cycles for on-premises data equipment. If I look at one of the existing clusters that I have from before, if I click on this one, for example, I have choices here like scale cluster. So if I say this is an existing cluster, and today I decided, hey, this is too small. It had 8 nodes, but I want to increase that. I can come in here, type a new number, save, and this will now start to scale. Now, it'll take a few minutes again, but it'll go get extra machines for me. It'll add them to the cluster. I can scale down, I can scale up. So this is, when I say making things easy, this is one of the ways, or part of that making it easy is the whole setup of the big data environment. You don't have to do much, you don't have to know much about the technology even. You can come here, you can get this started. So let me switch back to our presentation. So I think you've seen this slide already, so I won't spend too much time on it because we are running out of time. Cortana Intelligence Suite is what we call the collection of services that enable that Lambda architecture, that enable big data architectures in general. And some of my previous slides were based on this kind of framing. But so you have, from left to right, you have stuff about acquiring and capturing data. That's the information management side. You have places to store stuff, which is the big data store layer. Then you have the actual machine learning and analytics services. So these are all the actual names of the services in Azure that you can get to. And on the far right are the sort of the cutting edge capabilities that we've packaged, Microsoft has packaged into APIs that you can add on top. So cognitive services, bot framework was in the keynote. You saw some of that happening. Cortana capabilities. You can get all of these for very little work, essentially. So let me go forward here. So in terms of big data capabilities, there's kind of a couple of choices you have, especially in Azure. On the bottom, on the storage side, as I mentioned, you have the choice between Blob Store and something called Data Lake Store. So Blob Store is what you're used to. It's you get a Blob storage account. It has some maximum amount of data you can put into it, and whatever you put in there is just blob, as it says. It's binary data. You understand how to deal with it. Data Lake Store is the scalable big data store that we have. You sign up for an account, just like I showed you in a moment ago. You go and create, actually with less steps, you create a storage account. And after that, there's no inherent limit on how much data you can put in there. As you put data in, we charge you by the gigabyte of storage. You can have a terabyte today and 100 terabytes tomorrow and get to a petabyte scale. You don't have to create a new account for any of that. So the system understands that you are going to be storing big data, and you can grow arbitrarily. Individual files can be also arbitrarily big or small. So it's architected for enabling you to do IoT scenarios where you have millions of small files, or more classical batch scenarios where we have a smaller number of very large files. So Data Lake Store is tuned for analytics workloads, both in terms of transfer rates, but also in terms of being able to scale and grow naturally with you. On top of that, you can do a few different choices. You can say, I want Hadoop, but I'm going to manage everything myself. It's IaaS. So give me a bunch of VMs from the marketplace. I'll go get a Hadoop load and put it in there. We have Hortonworks, Cloudera, MapR. You can do that. The next step over is what I was just showing you, which is HD Insight. You say, why don't you do that for me? I'll tell you how many nodes I want, and sometimes I'll make that more or less. I'll grow it or I'll shrink it. You take care of everything else. You install the software. If a node goes down, you bring one up to replace it. I don't have to worry about how the cluster runs for the most part. And then the Data Lake Analytics is a big data as a service. So on that one, again, in some of the sessions you saw USQL being shown. This is where we're saying we actually abstract away the hardware for you almost completely. You don't think about cluster. You don't think about how many nodes I have and what kind of stack is running on them. You just think about the query. You think at the level of USQL, which is a combination of T-SQL and C#. You write your queries and you submit them to the Data Lake Analytics service, and we'll compile it, we'll optimize, we'll figure out that you could use 100 nodes or 1,000 nodes. You can give us a limit. You say, I don't want to go more than this, because that's how you control your cost. But we'll figure out how to run that for you. So let me just actually show you a picture of that to sort of help imagine what that looks like. So let me just switch over to Visual Studio. So our key tool for developers working against big data in Azure is Visual Studio. So we have if you look here on the Server Explorer, let me just zoom in a little bit here. So you'll notice Server Explorer lists your Azure subscriptions, your Azure services. Here you'll see Data Lake Analytics, you'll see HD Insight. So I can come in here and start to explore what I have. So in Data Lake Analytics, I have a number of accounts. I can go to any one of them, and I'll see in here, let me actually just go down to Data Insights. Let me go to this one. You'll notice that there are that there are under each account, these are ADL accounts. We have things like databases, so you have structured data, you have jobs that we've run here, analytics queries. We're running a bit short of time, so I won't show you all of this. I'll just jump to an example of a job. So if I look at this job, which I had already opened previously, let me just make some of this smaller. So this is showing a job that already ran. When I say job, I mean that this is a useSQL query. Let me just open that query for you. If I hit on the script link, it will open for me some useSQL. So useSQL looks a lot like SQL, except that it has big data additions. Here you'll see, for example, an extract statement, which is that schema on read we were talking about. So first thing you have to say is, I take a text file or a CSV file in this case, and map out what the columns are there. I tell the system, when you read from this file, these are the columns you're going to find. And I use an extractor, which is a kind of piece of code which you can actually overwrite. I use that extractor to write C# that tells the system how to how to understand that data. So there's extract statements here. If I go down a little bit more, it does a whole bunch of extractions. Eventually it gets down to doing a bunch of selects, so more T-SQL-like things. So we've written this whole script, and we have already run it, and it resulted in this execution plan. So this graph you see is the actual execution in the cloud. And if I come over here a little bit, you'll notice that this job took about 4.5 hours to run. In that 4.5 hours, it actually did 768 hours of computation. So 768 CPU hours of work, basically. And you'll notice down here, it read, shows you kind of the amount of data read. The interesting part, it'll say something about total vertices. So a vertex is one kind of execution environment. You can think of it as one node with a certain amount of memory, a couple of cores that was used to run a portion of this execution plan. So this job actually ran over 60,000 vertices. So in this 4.5 hours that it did its work, it actually leveraged 60,000 processing units. Now some of those were the same processing unit being used in different stages of the job. But you can see that we've unleashed a really large set of resources during this job's execution. And I'll show you what that looked like. So this job graph, I can animate this job graph for you. I can hit this playback, and you'll see how the job ran. So we're now showing you the execution of the job, which was 4.5 hours, over a shortened time period, like over a 30-second time period. And the flowing green is kind of showing you which stages, which parts of the query were running at a given time. This view, this is one of our debugging views actually, because it kind of helps you to see where things might slow down, where bottlenecks might be. So you'll see the time scale at the bottom is flowing, and you'll see at the upper right, there's still a couple of white boxes. So it took us to the very end. I can actually just drag this bar around to see at any given time where things were at. But you'll notice that at different points, there are different extract stages and different pieces of this job that cause slowdowns or where the time is spent. But the reason I wanted to show you this mostly was to help you visualize the idea of what Azure Data Lake Analytics looks like. So when I say job service, it's talking about saying you write a query, and then you don't think about, how do I parallelize this thing, or how many machines can I run it on. You let the compiler and the optimizer for uSQL do that. And the results can be quite stunning in terms of how many resources you use. All right, let me just switch back and finish off here. We're running out of time, so let me go back here. So I had a few more slides, but as I said, we're kind of a bit short on time here. So if you are interested in learning more, there's resources here about how to get some more information about Data Lake. Some of the customer cases and architecture diagrams I mentioned are on there. Of course, this whole slide deck will be available to you on the site as well for use later. So yes, we're just over time. So I apologize that I ran over the question time, but I'm here Afterwards, if you want to speak to me, also meet the speaker this afternoon from 2 o'clock onwards. We'll be in the meet the speaker room, so please feel free to come by and say hi. Thank you very much.